All right, as we continue to talk about our angles and arcs, we want to remember what we've already done. Remember we talked about when the angle has its vertex. Here's the angle. And then here is your intercepted arc. When your angle is in the center, when your vertex is in the center of the circle, then your angle is equal to your arc. And so in this case, then x is equal to n. Angle equals the arc. When your vertex is on the circle, here's your angle. And notice how we only capture one arc. Right? The vertex, if we trace our angle, we only capture one arc. Same thing here, we only capture one arc. Notice then that your vertex is on the circle, that your angle is, if this is my angle and this is my arc, same thing here, my angle is equal to half of my arc. Now, what we want to look at today is what happens when the vertex is outside the circle. So notice right here that my vertex is outside the circle. And if you trace the sides of your angle, what you'll notice is that the angle hits here and here. What happens is it breaks that arc into two pieces. Okay, you've got this outside or this far arc, and then you've got this inside near arc. Okay, but your vertex is outside. We've got the same thing happens here. Your vertex is outside. We're going to cut through our circle. We cut through here and here, here and here. Notice it breaks it into four pieces. Again, we've got this far arc out here that's intercepted, and we've got this near arc right here. And then this last situation, this is two tangents, this is two secants, and this is a combination of a secant there and a tangent there. It breaks that hoop up or that circle up into those pieces there. You've got your far arc out here, and you've got your near arc inside. Now, if you'll notice, if you look at the equations, notice that none of the equations are different. They're all the same. So when you do a vertex that's outside the circle, it's the same thing. You're going to take half of the difference. Okay, half of the difference. Difference means to subtract. So you're going to take half of the difference between the two arcs that are in between the circle, the intercepted arcs. Okay, so let's look at what this could be like. So we notice, so later on they're gonna be all mixed up, so you'll have to pay attention to where the vertex is. Right now we're still focusing on the same thing. So I have my angle, here is my angle. The vertex is outside, so I instantly know that my angle is half of the difference between my arcs. I like to write it like that so that I can see it. Now, another thing that I think is helpful is to color in the interior of that angle. When you color in the interior of that angle, then you can see only the pieces that you need to see. So you've got the number for your far arc, you've got the number for your near arc. So you are going to say then that angle 1 is equal to half of the difference, 119 minus 67. Now be careful with your calculator here. You don't want to do 119 minus 67 divided by 2. If you do that, the only thing that's going to get divided by 2 is the 67. So you either want to do parentheses, 119 minus 67, and then divide by 2, or you want to do 119 minus 67, enter, then divide that number by 2 and hit enter. Either way, notice that you get 26. So the measure of angle 1 is 26 degrees. Okay, look at the second problem. So again, highlight that angle. Notice where the vertex of that angle is. It is outside. Instantly, I know when it's outside that the angle is equal to half the difference. Okay, so half the difference of what? Well, here's where we run into a problem. Okay, now let's highlight it so we can see it. Unfortunately, highlighting it doesn't limit anything for me. So kind of like a puzzle, we have to figure out, okay, well, what else do I know? Because I've got to be able to subtract this arc minus this arc. Well, since the sides of this angle are tangents, they bisect, or not bisect, they cut this circle into two pieces, this outside piece and this inside piece. Well, full circle is 360. I'm going to subtract 360 and 138, and I get 222. That means this arc is 222 degrees. Now I have the two arcs that I need, my far arc and my near arc. So the measure of angle 1 is equal to half of 222 minus 138. 222 minus 138. When you do that, do 222 minus 138, enter, divided by 2, or type it in like this and use parentheses, and you get that it is 42 degrees. Now be careful, just because you subtracted here does not mean you subtract and then divide by 2. Don't get in that habit. Sometimes you have to subtract just to get the pieces that you need. Okay, sometimes we have to go to the store to get chocolate chips so that we can finish off our chocolate chip cookies. We have to go get our ingredients so that we can come back and finish what we were doing. Okay, so we have to go get this 222 so that then I can do what I need to do with my recipe. Okay, question 3. The measure of angle 1. So we're going to trace angle 1 so that we can see where it goes. I'm losing my marker here. Okay, the vertex is outside. I know that that means that the angle is half of the difference. Well, half of the difference between what two arcs? Okay, notice before we only had one arc. Now we have two arcs. That's why we have to actually do something with it, not just take half or leave it the same. So I need half of those two, the difference between those two arcs. We got to go to the store and get what we need. I'm going to add the 104 and 104 and 111. And then I am going to subtract that from 360. So you add 104, 104, and 111. You get 319. And you subtract that from 360 and you find out that this arc is 41 degrees. Now you have the pieces that you can subtract. So the measure of angle 1 is equal to half of the difference between 111 and 41. 111 minus 41 is 70, and half of 70 is 35 degrees. Now, we need to update this problem. It may already be updated for you, but if not, edit your problem so that it looks like this. So we need for it to pass through. Okay? We need we need them to be secants instead of tangents. This problem won't work with the lines this way, and I didn't catch it until now. Okay? So same thing. Now, here's something you need to notice. Notice that I gave you the angle this time, and I want you to find the other arc. That's okay. We have a formula to do that. Same process. Notice that the vertex of the angle is outside. We trace the sides of our angle. We only care about what is intercepted in between the pieces of the angle, the sides of the angle. So we only care about those two pieces. Now, I don't have any way, because I have these leftover pieces, I don't know how big x is, but that's okay. I do know in this case how big the angle is. Okay, so we know that because the vertex of the angle is outside, that the angle is equal to half of the difference. So all you're going to do is set up the formula. The angle, which I know is 47, the angle is equal to half of the difference, 201 minus x. Now, if 47 is half that, then we can, one easy way to deal with that 1/2 instead of distributing and having to do it that way, how about we just double this 47? If we multiply, if 47 is half of the difference, then the difference between them would be equal to 47 times 2. So we can multiply that 1/2 before we distribute it. So that means 94 is equal to 201 minus x. Much easier, right? That's a much easier problem to deal with. So we would subtract 201 from both sides. 94 minus 201 is negative 107. We have negative 107 is equal to negative x, or x is equal to 107. So that arc is 107. It's not just about finding the angles, it's also about finding the arcs. When the vertex is in the center, the angle is equal to the arc. When the vertex is on the circle, the angle is half of the arc. And when the vertex is outside, because it intercepts two, the near and a far arc, it is half of the difference.